To understand the logic of why finding an inverse matrix by row operations works, we briefly have to go over elementary matrices. An elementary matrix is an identity matrix with one operation performed on it. Here are three examples. The first example has the first row multiplied by 2. The second example, row 1 and row 2 are interchanged. And the last one, we have row 1 and add it to row 2. All of these are elementary matrices. They have one operation performed on them. Taking an elementary matrix and multiplying it by some other matrix A that is not an elementary matrix, although it can be, the effect is that it performs the operation E on A. So for the first example, if A is not an elementary matrix, then we multiply 2 times the first row of A, because that is the operation of elementary matrix. Well, let's call this one A. Elementary matrix B, row 1 and row 2 interchange. This, multiplied by A, will interchange row 1 and 2. C. On A, it will take the second row of A and add row 1. That's how multiplication of an elementary matrix against another matrix works. Take Take matrix A to be 2, 1, 8, 2. If this is a matrix, starting from an identity matrix, we can get to matrix A 2, 1, 8, 2 by performing a series of operations. Starting from the identity matrix, 2 times row 1 gives 2, 0, 0, 1. Row 1 plus row 2, 2, 1, 0, 1. Minus 2 times the second row, 2, 1, 0, minus 2. And then lastly, 4 times the first row, adding it to the second row, gives 2, 1, 8, 2, matrix A. We got from the identity matrix to matrix A by performing a series of simple operations, one operation at a time. Each of these simple operations can be taken to be an elementary matrix. So instead of writing it step by step like this, if one so desired, they could write it like this: 1, 0, 0, 1, the identity matrix. And the first step, 2 times row 1. This is the elementary matrix that would represent that. The next step, row 1 plus row 2. Took this row, added it here. This is elementary matrix 2. Second step, minus 2 times row 2. Here's an elementary matrix for that. And the last step, 4 times row 1 plus row 2. Here's a 4. And that is also an elementary matrix representation of this operation. So if someone wanted to, they can think of it as a multiplication of a series of elementary matrices to give A. E1 times E2 times E3 times E4 times E, and however operations are necessary to give this matrix A. So what that implies is, if it's just a series of operations to get from the identity matrix to some matrix A, then we can take these operations and perform the opposite. So here are the operations to get 2, 1, 8, 2 again. If we reverse the order of these, then it will take us back to the identity matrix. It's like following directions. You can take directions from your house to some location. In order to get back, you just do the opposite of what you did. If you turned right, then on the way back you turn left. And you follow the reverse order. The first step is now last, the last step is now first. So 2 times row 1 plus row 2, minus 2 times row 2, 4 times row 1 plus row 2. Now in order to get back to the identity matrix, which is what finding an inverse matrix is all about, start with the matrix 2, 1, 8, 2. Now instead of 4 times row 1 plus row 2, this is now row 2 minus 4 times row 1. Instead of minus 2 times row 2, minus 1/2 times row 2. Just doing the exact opposite of what we're doing. Row 1 plus row 2, row 1 minus row 2. 2 times row 1, 1/2 times row 1. So again, someone can think of matrix A as a series of elementary matrices to get from the identity matrix to A. So by the same reasoning, you can take these elementary matrices, do the opposite operations, and reverse the order. So now, starting from 2, 1, 8, 2, over here, we do the opposite operations, and in the reverse order. Instead of starting with E1, we start with E4. And here, I just wrote them as elementary matrices, instead of writing them out as operations. And that is essentially what's going on mathematically, fundamentally, when we're using this technique. Here we have matrix A, and over here the identity matrix. And what people do to find the inverse matrix is make this turn into this, make these switch spots. So we perform a series of operations on A to make it become the identity matrix. At the same time, we perform these operations on the right side. And the whole point of this is that what we're really doing every time we perform one operation over here and over here is multiplying it by an elementary matrix. So someone can think of it as a multiplication of a series of elementary matrices, the opposite of E4 times minus 3 to minus 2, however someone wants to think about it. You can think of them as individual units, but what someone can do instead is just multiply all of these individual elementary matrices together. And when someone does this, so start with this one, perform multiply this times this, then we get a result. Multiply this times the result, we get another result. Multiply this times that result, and we get the final result because we've run out of elementary matrices to multiply, and that is what this is. E minus 4, E minus 3, E minus 2, E minus 1, all of these multiplied together give this, and this is the inverse matrix of A.